On the abyssal plains, some 3,000 to 6,000 meters below the surface, that's where they grow. Dark brown rocks, no bigger than potatoes, often featuring higher concentrations of manganese than can be found anywhere above the surface. In 2017, researchers in Quebec found a hydrothermal vent containing fossilized microorganisms that may have lived as early as 4.2 billion years ago. These fossils are evidence of the oldest forms of life on Earth. The catalysts for this life were the vents themselves, great craggy towers which belch out hot, stinking water into the cool of the deep. In this water, roughly 254 picometer-wide manganese atoms combined with oxygen and iron, forming clumps which pick up other metals as they filter through the ocean. These clusters latch onto objects on the sea floor, sharks' teeth, bones from the ears of whales, even bits of basalt or clay. Around these nuclei, nodules start to form. Microbes and microalgae that attach to these nuclei act as bioseeds, attracting more manganese and iron. Over 1 million years, the nodules grow between 2 and 15 millimeters, which means this 7 centimeter wide nodule has been drawing in minerals from the water around it for the last 7 million years. It was in 1868 when nodules and humans first encountered each other. Since the second millennium BC, Egyptian glassmakers have understood that adding manganese to their glass could turn it violet, and that adding a little more could make it colourless. But their manganese was mined from ore deposits on land. It wasn't until the Swedish crew of the SS Sofia brought nodules up from the depths of the Arctic Ocean in 1868 that deep-sea manganese ever breached the surface. Next came the HMS Challenger. On March the 7th of 1873, just off the coast of the Canary Islands, the Challenger's crew brought up hundreds of nodules in their trawl net, the largest of which they described as being about the size of cricket balls. And then, for many years afterwards, there was almost no further contact between humans and nodules. By the 1950s, almost 100 years later, new efforts were made to collect and investigate these nodules. A consortium of countries formed to develop resource assessments and extraction technologies. Of particular interest to this consortium was a 4.5 million square kilometre area of the abyssal plain stretching between Hawaii and Mexico. Known as the Clarion-Clipperton Zone, or CCZ, the area was thought to contain about 5.95 billion tonnes of manganese. Scientists painted a picture of inexhaustible riches waiting to be plucked from the depths. Yet, at the United Nations General Assembly of November 1967, the Maltese ambassador to the UN, Arvid Pardo, encouraged a certain level of trepidation. In his impassioned 3-hour speech, Pardo urged the Assembly to designate seabed resources the common heritage of mankind. To him, as resources which lay beyond the jurisdiction of any one nation, these nodules should belong equally to all nations. His was a goal of using seabed resources to reduce global inequality. In a minor way, these nodules invoked a coming together of humanity, a unification which was ratified through the formation of the International Seabed Authority, an organization with 167 member nations, which was set up to regulate access to those areas of the seabed beyond national jurisdiction. In 2001, the ISA awarded its first deep-sea exploration contract. The contract gave an intergovernmental group exclusive rights to mine for nodules within a 75,000 square kilometre patch of the CCZ. Since then, each ISA contract that has been lodged has been accepted, with the ISA receiving roughly $200,000 per contract. By receiving this amount of revenue for each mining license issued, the ISA undermines its own capacity to remain vigilant as protector of the seas. By 2010, private companies joined national agencies in undertaking deep-sea exploration, and thus a nodule mining industry was born.
An
In
area
keeping
more
with
than
the notion of common
3,500 times the
heritage,
size of
the
Nauru.
ISA has given developing island nations access to various areas of the CCZ, and yet, as in the case of Nauru, this access is mediated by private mining companies such as Deep Green. As of 2018, the same company had also acquired the rights to the mining capacities of Tonga and Kiribati, island nations which now acquiesce to Deep Green in its mining monopoly. The nodules feature not only manganese, but also copper, nickel and cobalt, each of which the company needs in order to produce electric vehicle batteries. Deep Green couches their exploration in a rhetoric of innovation and sustainability, whilst maintaining and extending the same unviable logic of extractivism that we have at present. Corporate influence within deep-sea mining is so significant that during a February 2019 session of the ISA Council, Deep Green executives stood in for Nauru delegates, while executives from marine company DEM spoke on behalf of Belgium. When these executives speak on behalf of island nations, do they also speak on behalf of manganese?
For our children and their children well into the future.
In March of this year, the first ISA contract will expire. By the middle of the year, Deep Green expects to have mining operations underway in the CCZ. And what of 2034, the year when the ISA's most recent contract expires? Will green extractivism have adequately mitigated the impact of fossil fuel extractivism? What about the deep-sea organisms that are irreparably disturbed by even the slightest of mining or testing activities? How will their displacement affect the rest of the ocean's ecology? Whether or not the world will resemble the egalitarian global society envisioned during the UN Assembly of 1967, what's clear is that manganese nodules will play a major role in the reconfiguration of both maritime and terrestrial territories.